there are some people standing in a queue. Why are they standing there? Well, assume they're standing there to buy a ticket for a movie. Let me ask you a very simple question. How many people do you see in the line? The answer is 7. How did we get this number? What did we do in order to get the answer 7? Yes, we counted the number of people. 1, 2, 3, 4, 5, 6 and 7. A total of 7 people. We can also start counting from the other side. 1, 2, 3, 4, 5, 6 and 7. In both the cases, we get the same answer, 7. Similarly, if I ask you how many pens we see here, what will we do? Yes, we will count the number of pens. 1, 2, 3, 4. Hence, the total number of pens in the stand is 4. On the same lines, count the number of coins on this table and the number of rugs in the stand. One, 2, 3, 4, 5, 6, 7, 8 and 9. 9 coins on the table and 12 rugs in the stand. In all the examples, we are using numbers to count things. All these numbers are called counting numbers. Counting numbers are the numbers that we use to count something. 1, 2, 3, 4, 5 and so on are counting numbers. Counting numbers are also called natural numbers. Maybe they are called so because these numbers come naturally to us. These are the first numbers that we learn. Okay, so 1, 2, 3, 4, 5, 6, 7 and so on form natural numbers. Natural numbers start from 1. Now here is one interesting question. Where do the natural numbers end at? Or in other words, what is the largest or the biggest natural number? To get to the answer, you can help me answer these questions. Can we count the number of students in a grade 6 class? Yes, we can. Can we count the number of students in a school? Sure, we can count that too. Just count number of students in each class like we did previously and add them. The number of students in a school might be in thousands. It is obvious that the number of students in a whole school will be greater than the number of students in the grade 6 classroom. Now, can we count the number of people in the whole city? Well, it is getting quite tricky now. The answer to this question is again yes. But how? Well, to be honest, there are many ways in which we can do that, but we're not really interested in the way in which we can count. The point is that we can surely count the number of people in the city. There is definitely a number representing the number of people in the city, and this number could be in millions. It is obvious again that the number of people in the city will be greater than the number of students in college. Similarly, the number of people in the country will be greater than that in the city. How many people on this planet? How many people will exist on this planet in the next 10 years? And what about the next 100 years? So the question here is, what is the number we can count up to? From this example, we conclude that there is no such largest number that we can reach while counting. Or in other words, there is no largest natural number. Okay, I want to discuss one last topic before ending this lesson. Here is an example that we have seen a little while ago. 7 people are standing in a queue. Say one more person joins the queue at the end. How many people are there now? 8, right? When we add 1 to 7, we get 8. 8 is called successor of the number 7. Whenever we add 1 to any number, the new number that we get is called the successor of that number. So on the same lines, what numbers will succeed 18, 85, 562 and 10,381? When I add 1 to 18, the number I get is 19, and hence 19 is the successor of 18. Similarly, when I add 1 to 85, the number I get is 86. So, 86 is the successor of 85. Similarly, the successors of final two numbers are 563 and 10,382. This was about the successor of any number. Now, can you tell me what can be the predecessor of any number? Yes, when we subtract 1 from any number, the new number that we get is the predecessor of that number. For example, take these three numbers: 108, 200 and 1000. I want you to tell me the numbers that precede these numbers respectively. (108 minus 1 is 107. So 107 is predecessor of number 108. Similarly, 199 and 999 are predecessors of 200 and 1000. Let's take bigger numbers and try to find their predecessors. We've seen before how these large numbers are written using words. This reads as 3,33,462. And this one reads as 78,93,424. When we subtract 1 from these, we get 3,33,461 here and 78,93,423 here. So these two numbers are predecessors of these two. In the next video, we will introduce the concept of whole numbers and learn how to represent them on a number line.